After this example, you will be able to analyze a retaining wall. Example 2. A gravity retaining wall is shown below. Use delta equal to 2/3 phi and Coulomb's active earth pressure theory. Determine the factor of safety against overturning, sliding, and the pressure distribution at toe and heel of the retaining wall. Here is a gravity retaining wall. The type of the retaining wall is gravity and depend on the block of the concrete and the weight of the concrete. In this example, the active earth pressure will be computed based on the theory of Coulomb. The active earth pressure coefficient will be computed based on the equations proposed by Coulomb. Now start with the H. H is the height of the retaining wall, the total height of the retaining wall from the top of the retaining wall to the bottom of the base. Here the backfill, the surface of the backfill is horizontal, and since there is a friction delta here between wall and soil, we have to use Coulomb active earth pressure theory. We will use the following equation of active earth pressure coefficient equal to sine square alpha plus phi. This is a general equation to compute the active earth pressure coefficient for retaining wall. Retaining wall has a friction between the wall and the soil, adjacent soil, and also the wall is tilted with an angle, and the surface of the backfill may be tilted also. Alpha equal to 75 here. Alpha, this angle is alpha, and beta equal to 0. Beta is the angle of the back surface. The back surface here is horizontal, or beta equal to 0. Delta equal to 2/3 multiplied by phi. Phi is the angle of internal friction. Phi equal to 32. Now replace alpha and beta with their values. Gives us K active equal to 0.4016. Here alpha equal to 75, phi equal to 32, and delta equal to 21.3. After computing the active earth pressure, we have to compute the P active. P active equal to 0.5 gamma H square K active. 0.5 gamma equal to 18.5, H equal to 6.5. Since the distribution of the pressure acts on the retaining wall is triangular, therefore this is sigma vertical equal to gamma H, and this is H, gamma H multiplied by H over 2.5 gamma H square multiplied by K active equal to 159 kilonewton per meter. Now compute pH and pF. Resolve this active earth pressure resultant, the resultant of active earth pressure, to horizontal and vertical forces. Multiplied it by theta. Something important here, that the resultant is tilted. This is the resultant of the earth pressure, is tilted with the vertical line to the wall by an angle equal to delta. First we draw a vertical line or a line perpendicular to the wall, then the resultant is tilted by an angle delta. Therefore, the horizontal force here, if you want the horizontal and vertical, if we want the horizontal force will be this angle equal to delta plus this angle. Since this angle equal to 75, therefore this angle equal to 15, and this will be also 15. So the total angle will be delta plus 15. Delta is 2/3 multiplied by 32 plus 15. The value of this force times cosine this angle gives us the horizontal force, times the sine this angle gives us the vertical force. Here, according to DAS, because we use the column theory, this section of soil is not included in the weights, is not included in the calculation of weights. Now pH equal to PA cosine theta, theta, as we mentioned, theta equal to delta plus 15 equal to 36.3. PV equal to 92. Now compute the weight and the moment acts on the structure. We have to divide this section into 4 areas. The first area, this is rectangular section number 2, and the base, if we have a geometry for this part, we have included it. If we don't have, we can ignore it. Section 1, section 2, section 3, section 4. All the sections are concrete. Section 1, compute the area, multiply it by the gamma of concrete, and the arm from, this is the point of our turning, the arm from the middle of this part to this point, the arm from the middle of this part to this point, the horizontal arm, and from 1/3 here, and also from 1/3 here to this point. Then multiply the weight by the arm and obtain the moment. Here we need the total weight and the total moment. To compute m0, which represents the applied moment, pH multiplied by h/3 gives us 274. Factor of safety against overturning, summation of the resistant moment over m0 gives us 2.67. Greater than 2, it may be accepted. Factor of safety against the sliding, also the vertical force total here, the base of the retaining wall, the resistance force here, and this force try to slide the retaining wall, and this force resist the sliding. Total V multiplied by the tan 2 over 3 phi, 2 over 3 phi, and B multiplied by 2 over 3 C2. The force come from cohesion, and the force come from the passive in front of the retaining wall, divided by the horizontal force from the active earth pressure applied on the retaining wall. Factor of safety against sliding equal to 2.84, also greater than 2. It may be accepted. If the PB, passive pressure, is ignored, the factor of safety will be reduced here. If this value is ignored, the factor of safety will be reduced to 1.37. Stress distribution can be obtained by first computing the eccentricity B over 2 minus resistance moment minus M over V gives us 0.483, which is less than B over 6. Q at the 2 equal to 188 here, and Q at the heel equal to 17. Here is 188 kilonewton per meter square, and here is 17 kilonewton per meter square. The stress distribution at the 2 and the heel. This is the 2 and this is the heel of the base of the retaining wall.